In this video, we're talking about how to solve one variable inequalities. So these are really similar to just solving one variable equations where there's an equal sign. The only difference is at the end that your solution means something different, but it's still going to be the same steps. So when I look here at number 1, so 2x is greater than 4. If I want, I'm just going to put an equal sign for the time being and just kind of think of it that way. So if I can solve an equation, I can solve an inequality. So remember, we're always thinking about what's the opposite operation. So if I have 2 times x on the left side here, what's going to be the opposite of multiplying by 2? Well, that's going to be dividing by 2. So I divide by 2 and divide by 2. Okay, so 2 divided by 2 is 1. So I'm just left with x on this side, and then 4 divided by 2 is 2. So the only thing I need to do at the end here is whatever my inequality was up here, I need to plug it back in for the equal sign down here. So now I have x is greater than 2, and that's going to be my solution. So again, it's still the same steps as solving for x in an equation, but now I just need to graph my solution. So, okay, so x is greater than 2, so let me put my boundary point at 2, and remember it's going to be open because it does not have the line under the inequality. Okay, and then let me use a test point. What's a number that's bigger than 2? Well, I could plug in like 3 because 3 is bigger than 2. So I put my little test point right here, and so I know that my arrow is going to go to the right. That's it. So you just solve it and then you graph it. All right, let's do number 2. Okay, so we have 3x plus 1 is less than or equal to 10. Okay, so same thing as last time. I'm just going to rewrite this with an equal sign just to make it, like, you can keep the inequality, but putting the equal sign just kind of reminds me like, oh, I'm just going to solve it like a normal equation. Okay, so let me put my line down the middle. Remember, I want to get all the units on one side, so I want to get rid of this positive 1 right here. So what's the opposite of adding 1 or positive 1? That would be subtracting 1 or negative 1. Okay, whatever I do on one side, I have to do on the other side. Okay, so I have a 0 pair right here. So if I bring down what I have left over on the left, I just have 3x equals, and then 10 minus 1 is 9. Okay, so now what's happening to x? Remember, there's an invisible dot here. So this is 3 multiplied by x. So what's the opposite of multiplying by 3? That would be dividing by 3. So divide by 3, divide by 3. So again, 3 divided by 3 is 1, so that cancels out. So I have x equals 9 divided by 3 is 3. And again, I want to take this inequality and plug it back in at the bottom down here. So I have x is less than or equal to 3. And that would be my final answer. So now I just want to graph that. So again, I put my dot at 3. And I know it's going to be a closed dot because we're looking at less than or equal to. So it'll be closed. So I come here and I put a closed dot at 3. Okay, and then which way does the arrow go? So let me plug in a test point over here. So what value can I plug in for x that will make this inequality true? I could pick like 1 because 1 is going to be less than 3. Okay, so 1 is over here. So I know that my arrow is going to go to the left. Okay, so again with these, you're just solving for x like we would in an equation, and then at the end you just graph your solution.